Highly welcome to today's class. I remain your facilitator, lecturer, Dr. Nathaniel Obasi. I want to welcome you to today's class. Sorry I couldn't hold the class yesterday, but I also communicated you earlier, letting you know that the class has moved to the same time Friday, 2 to 3 p.m. Friday. So you're highly welcome once again. Today we are going to be talking about a very interesting topic. We're going to be talking about a very interesting topic, that is profile description and soil surveying. We need to talk about soil profile. You can't study soil science without good understanding of what a soil profile is. So you cannot carry out an effective soil survey without having an understanding of what a soil profile is. It is the information we got or gotten from soil profile that we use in soil classification. And that is the basics. That is the basis for soil survey. That is why this topic is very important. You can see a prototype of soil profile on the screen, and see a diagram of soil profile on the screen. And generally, you have the topmost horizon on the soil profile piece to constitute O horizon. O horizon. It's usually not too thick, such. It's light, it's a bit of flat, not as thick as some other horizons as such, then followed by A horizon. By the A horizon, you have the B horizon, then the C horizon. If you go further, you can even have R horizon. Then, what's the significance of this O horizon? O simply means organic. Organic simply means something that is or was alive. Something that was once alive and is dead, and the product from its decomposition is what has precipitated into what we are having. The composition stage may not have been final. There could still be some debris of litter, fallen leaves that is yet to be completely broken down, trees that have logs of trees that some part of it may have decomposed. By all means, we're talking about something that's derived from a living thing. That is organic. That is organic. So as it, this kind of horizon, you see it from a very thick forest, where you normally have decayed leaves or decayed plant substances littered all over the surface of the soil. And after that, you have the A horizon. A horizon may be horizon that is under cultivation, the part of soil that is normally utilized during cultivation. A horizon. You can see that after O horizon, you get the A horizon, and the A horizon can be still dark, but not as dark as the O horizon. And after that, you begin to meet the mineral materials, which is the B horizon. Now, there is something, if you check the space between the A horizon and the B horizon, there is a kind of very light horizon that is not so easily identified. It is what we call E horizon. E. It is not in this diagram you are seeing now, but in practice, when you dig a soil profile pit, you likely see it. This E horizon is the interface between the A and the B horizon. And one of the significance of that is that this E horizon is the horizon in which materials have been washed out into B horizon. Materials, there is a material movement, also known as alluviation. So it's an alluviated horizon. It's a horizon in which materials are constantly being moved from, say, A to B horizon. And the B horizon, the B part in which these materials that is being moved out of E horizon enters is the alluvial horizon, alluviation. Alluviation is taking place. What are those materials that move out of these horizons? Those materials may include things like organic matter. Organic matter are part of the materials that move from those E horizon to B part. There's also what we call sesquioxides. Sesquioxides are oxides of aluminum and oxides of aluminum and iron. They are also part of materials that move out to join this horizon. Excuse me. So what are we saying in effect? What we are saying is that these horizons are very, especially the B horizon, they have some materials that have been moved from A horizon into it. And another major accumulation, another major thing that also gets accumulated in B horizon is clay movement, clay accumulation, and clay movement, so to say. And that's what brings about what we call agilic horizon. Agilic, agila, is a Greek word, Latin word that simply means clay. So when we talk about agilic horizon, it's a horizon in which there is clay accumulation in it. Candic horizon is a horizon in which there is consistent clay movement down it. Candic horizon, there is clay movement in down from it. So in that order. So that is what we'll be looking at today, and we call it soil profile description and soil survey. So we now say that, what is soil survey? A soil survey describes the characteristics of the soil in a given area. Yes, soil survey talks about the characteristics of a soil in a given area, and it classifies the soil according to a standard system of classification. plots the boundaries of the soil on a map and makes prediction about the behaviors of the soil that study. So the different uses of the soils and how these soils respond to management effects are also considered this study. So the information collected, the soil survey, will help in the development of land use plans, help in the evaluation and prediction of the effect of land use on the environment. Maybe asking what's a soil or what is a soil profile? Profile is a side view of a person. Profile, a side view. When you cut through a soil surface, as you are looking at one side of it, it's called profile. So, so a soil profile must be the side view of the soil. And there are no fixed number of horizons. The soil profile would much depend on the age and weathering process going on the soil. So you now see that it is not every soil profile or soil you see that has O horizon. O horizon is peculiar to soils that are from probably a forest soil, tropical forest soils, in which the leaves of trees will keep falling until they will form a flat layer on the soil, in which you see both partially decomposed and completely decomposed part of this material that are falling on these leaves. Yes. So, but however, not every soil have this soil that have this O horizon. Some soils, such as empty soils or insecty soils, they don't have much horizons in display because they are young soils. They have not passed through pedogenic processes that would have been able to bring out some of the embedded horizons on this soil. So a soil would have the following horizons. For example, have horizon A, have horizon A. Of course, horizon A sometimes, horizon, first layer, is the top layer of soil. And we say that animals live on this layer. Animals normally live on the topmost part of the soil horizons. And some of these animals we're talking about here may not be very large animals. Might just be earthworms, might just be ants, might just be some micro and macro organisms that move around. So it is made up of fresh to partially decomposed organic matter. So the color varies from brown to black. Color of the topmost horizon vary mostly from brown to black. Why is this color? It is because of the organic matter presence of this horizon that kept constantly subjecting it to this brown to black color. So now the second horizon sometimes, remember the first horizon is the O horizon, then the second one is the A horizon. And the top part of this soil, top part of this soil is made up of highly decomposed organic matter mixed up. However, the color ranges from brown to gray. We talk about after the O horizon. The A horizon usually have a variation in color that varies from brown to gray. Brown to gray. So now, I also, in my introduction, our explanation of the first slide there, I talked about E horizon. And this is made up of mostly sand and silt that migrates down, or the migration of particles that has lost most of its minerals and clay due to alluviation. I would say that it's usually light in color, and some of the materials in it has been washed off. Some of the materials in this horizon has been washed off. Because it has been washed off, the horizon becomes somehow light. Horizon becomes light. You now see some very light color somehow in between the E horizon and the B horizon. You now say that it's as a result of alluviation. There is alluviation taking place in such horizons. After that, you have the B horizon. And unlike the other horizons, this one has more clay as well as bigger bedrock. It's usually reddish or reddish brown or tan color. Now have the C horizon, and this has mostly weathered bedrock. It's the cracked and broken surface of the bedrock. That's the C horizon now. I have the R, which is the last layer in the soil profile. It's made up of unweathered rocks. And what is soil profile, or what is a profile? Soil profile refers to the layer of soil, horizon A, B, and C. Horizon A refers to the upper layer of soil nearest to the surface, and it is commonly known as topsoil. In the woods or other areas that have not been plowed or tilled, this layer would probably include organic litter, such as the fallen leaves and twigs. So the litter here helps prevent erosion. Litter will help to prevent erosion and will help to hold moisture as well as decays to form a very rich soil known as humus. So horizon A provides plants with nutrients that they need for a very good life. So that is why the further you move from top horizon, the less fertile a soil is. Less fertile that soil likely be. The further you move, the more you move away from the topmost horizon. The reason is because this topmost horizon is where the leaves, where we dump our refuges, which decompose, where there are activities of microorganisms working to break down these organic materials into a form that can be utilized. And of course, plants do not use nutrients that are in the organic form. They need to be broken down into the inorganic format of, say, nitrates, sulfates, or ammonium ions, These are all inorganic forms in which nutrients could be taken up by plants and utilized. So the layer below A is the B horizon, and later is not present in the B horizon. Therefore, there is much less humus. Horizon B does not contain some, horizon B contains some elements from horizon A because of the process of leaching that takes place. So leaching resembles what happens in a coffee pot as the water drips through the coffee ground. So leaching and in the sense of cultivated soil. So soil mixing may also bring some minerals from horizon B down to horizon C. So if horizon B is below A, then C must be below B. Horizon C consists mostly of weathered big rocks. Weathered big rocks. So this solid rock, as you discovered in soil formation, gave rise to the horizon above it. Weathered rock, or the solid rock discovered in soil formation, give rise to the horizon above it. That is why they are called the parent material, the parent in which these soils are formed from. So soil profile look different in different areas of the world. They are affected by climate and other things. So soils are structural and functional elements of terrestrial ecosystem, which are formed in a historical process of development through the interaction of geological, climate, and biotic factors at the respective site. Yes, so soil is the fundamental source of life. Soil is the fundamental source of life for all living things. So as the physical and chemical properties of soil exert great influence in the distribution, development of vegetation, it needs to be studied and evaluated even from time to time. So what are the types? We have sandy, we have sand, we have seed, we have clay. That are the basic particles in a soil. Most soils are made up of a combination of three. So the texture of the soil, how it looks and feels, depends upon the amount of each particle in that soil. Depends on the amount of each particles of sand, seeds, or clay that are in that particular soil. That is what determines texture. If the soil has so much clay in it, means when you touch particle, it will be very sticky. So stickiness is a characteristic of clay. If it is very smooth in the hand, it is more likely to be sealed. If it's coarse, cracking in between your thumb and your forefinger when you are rubbing it against each other, it's now more like sandy soil, more sandy soils in it. So the type of soil varies from place to place, our planet, and even in our environment around our compound. So soil conservation. Soil conservation now says that soil erosion caused by wind and rain can change land by weathering down or wearing down the mountains, creating valleys, making rivers to appear and disappear. It is a slow and gradual process. Take thousands, even millions of years. So it takes quite a long time before soils form. It takes up to 1,000 years for soil to form. Certain instances. That is why we have to be very careful the way we manage our soil. For instance, now, if you scrape off the topsoil of a particular farmland, remember the topsoil are the areas where the nutrients, these soils are contained. That is where we have organic matter. That is where we have the microorganisms that decompose the organic substances on the surface of the soil. And as they decompose these materials, they bring them to a form that can be used. They bring them to the form in which plants can pick them up and use them. So erosion may be speeded up greatly by human activities such as farming and mining. So soils develop very slowly over a long period of time, but can be lost quickly. To expose the particular soil to erosion forces, it just takes probably just one rainy season. Now realize that a particular farmland would have been devastated, or erosion would have taken place, creating gullies. And such soils will definitely not recover from such situation in the recent time. So that is why it is very, very important that we begin to think of how to preserve our soils by creating drainage channels, creating avenues in which water from the rains can easily be discharged to the appropriate locations where they ought to be. Water from the rains can easily be discharged. And we're also careful the way we carry out our mining activities on the soil, because some of these activities end up predisposing the soil into a very dangerous outcome. So the clearing of land for farming, residential, and commercial use can quickly destroy soil. So it also speeds up the process of erosion by leaving soils exposed, and also prevent development of new soil by removing the plants, animals that help to build up the humus. If you remove the trees on the surface of the land, remember the trees, they are the ones that discharge their leaves to build the humus content or the organic matter content of the soil. So when you now fell off all these trees, where will this organic matter come from? So we certainly these soils will begin to be predisposed to a situation in which organic matter content have been lost, and before you know it, the fertility of that soil would have also been lost completely. Now, we have to talk about soil survey briefly before we end this topic. Today, we have to talk about soil survey. While we were talking about soil profile pits, and soil profile is a building block to soil survey. Soil profile information from soil profile is what we use to classify soils, and soils classification is needed in soil survey information. So soil survey or soil mapping, the process of classifying soils or soil types and other soil properties in a given area, as well as geoencoding such information. Geoencoding is another word for digitizing, putting them in a form in which you can easily access them, either in a database, whereby when you are searching for certain information, you can, you will be able to get it from a particular website, from a particular database, and those information gotten from this source can be used in taking some management decisions about the source that is in question, the soil that has been studied. Provides information to people who want to use that soil, probably as farmers, probably as policymakers, or even governments, or agriculturists, agricultural development agencies, when they have access to certain information about these soils. You help them as you want to go and invest in such soils. You need to look at that soil. What is the history of that soil? What is the fertility status of that soil? What is the use that this soil has been subjected to in the past? And how can this soil be used now for profitability? So if such information is lacking, then obviously you cannot be able to make good management decisions about such soils. So now you say that soil survey applies the principle of soil science, draws from geomorphology, and it also draws from theories of soil formation. It uses physical geography and analysis of vegetation, as well as land use patterns. All of these are very, very vital when we talk about soil survey information. So the primary data for soil survey are acquired by field sampling. Primary data that we use are gotten from field sampling, supported by remote sensing, principles of area photograph. These are some of the things used. So the term soil survey may also be used as a noun to describe the published result. Soil survey can be used as a noun to talk about a published result. In the United States, these soil surveys have been published in books or in book form for individual counties by the National Cooperative Soil Survey. So the information is used by farmers, as I stated earlier, ranchers, to help determine whether a particular soil type is suited for crop or even livestock, and what type of management might be required in such soils. An architect or engineer might use the engineering properties of a soil, I mean, whether or not such soil is suited for a certain type of construction. What are the components of soil survey? Soil survey have certain components. They include typical information in a published soil survey report will include the following: a brief overview of the country's geography, a brief overview of the geography of the location that is being studied. You try to describe the landscape, talk about whether there are water bodies, whether there are hills, what are the vegetation, what are the streams that pass through those areas, what are the existing information. Most cases, you just look at the environment there and try to describe how that environment looks like. You also, part of the component include a general soil map with a brief description of each of the major soil types found in the area, along with their characteristics, as well as the detailed area photograph with specific soil types outlined as well as indexed. We talk about area photograph, we're talking about photographs taken using an aircraft, so to say. The photograph taken from afar, about an object from afar using area photograph or other facilities. So you now say that to describe a soil or for soil survey purposes, part of the component will include getting an area photograph of such location that is being surveyed. So soil survey, we also talk about photograph of some of the typical soils found in the area. We have tables containing general information about the various soils such as the total area, the comparison of production of typical crops and common range plants. They include extensive interpretations for land use or land use planning, such as limitations for dwelling with or without basement, shallow excavation, small commercial buildings, septic tank, absorption, suitability for development, construction and water management. So we have tables that contain specific physical, chemical, and engineering properties such as soil depth, soil texture, particle size, distribution, plasticity, permeability, available water capacity, shrink soil potential, corrosion properties, as well as the erodibility of the soil. A soil survey report should carry or contain information that is specific to a given form or upland use. So this is usually determined by the terms of reference. After soil survey, there's what we call terms of reference, TOR, that's usually sourced or gotten before you embark on soil survey. What are the things you need to capture? Those are the terms of reference, and to ensure that your survey contains all of this information. So conclusion, I would say that soil survey provides a field-based scientific inventory on soil resources, which includes soil maps, information on the physical and chemical properties of soil, as well as information on the potential and limitation of soil for various uses. So thank you for listening and being blessed. I will stop sharing now. I don't know if there is I don't know if there is any question. Musa, Mar, I don't know if you have any question before we end today's class, please. Can unmute yourself and talk, please.
Good afternoon.
Thank you, my dear. How are you?
Fine, thank you, sir. I don't have a question, so to say, but the question is just like how many class left, because this our course will be the first for our exam. It should be on 25th of this month.
Based on timetable, right?
Yes, it's first on the timetable.
Maybe shortly before that, I may have to do some classes to make it fast and do it sometimes, if possible, do 2 times in a week, because we are supposed to have 8. So this class is the 4th class now. However, even if I cannot complete it, because if I go by weekly classes, we will only have like 2 more classes now, isn't it? Before the before the distance, so still remaining 2. But one of what I assure you is that if you go to my page in the eLearn and you go for instructional video recordings, all the units have been captured there. You understand?
Yes, I understand.
So even if I did not, as in, if I couldn't cover it through this method, all of those at the instructional video levels, you will still listen to them. Then in case I don't have time to cover them, but I will still try the little I can cover it, okay?
Okay, sir.
I will try. So you can see
Thank
that
you.
we have done quite a lot in this course by producing instructional videos as well as by doing this facilitation. So there is, by all means, you have, support to guide you to be able to do well. Okay.
Okay. Thank you very much.
So God bless you and see you same time next week. If there is any development, I will still send mails to you people as usual.
All right. Thank you, sir.
God bless. Take care.